n minus ma plus mg equals 0. That would be the condition for this. So if you look at the whole three systems, it depends where we define the system. If we consider the whole objects or part of this, then the internal force here is not important for the movement, but here then the force between the object is going to act on and affect the movement of the object. And this is very important to digest when you want to analyze the Newtonian mechanics system. Now let's move on and bring a different example. Suppose you have three objects, A, B, and for example, C is a bit bigger, it can be different, and then the system is acted by a force, external force like F. Now, if I consider the whole things as a system, then the forcing that acts on this system, you could say there is a frictional force for the considering the whole thing as a system that we consider F. So the equation of motion is F minus F equal to the mass of the whole system, which is ma plus mb plus mc times the acceleration. But how about if I consider, for example, C as the system? So you have this force, you have the frictional force, but because we are considering only C, there is a force from the surface of A, which is pushing this direction against the movement of the C. So that would be F A to C. This is the force between these two objects. And for this condition, then F minus F plus FA to C is equal to MCA. Only the mass of the C when you consider. Now imagine I consider the A, my system. So this is F acting here. If I consider A as a system, then F is not acting on A. So F is not going to be a force for case that A is the system. The only force acting here is the frictional force here, which this is considered to be Fa. And let me just put this one also Fc, because this friction is only applies to the mass M, whereas this friction is actually the first case is the friction between every object and the surface. And we will discuss about the nature of these frictional forces, because we know briefly, if I say friction is mu n, and for every of them we could say Fa is mu a times Na, and we know the Na is equal to the mass of the object A, so we can say this is mu A, Ma, G. This is Fa. The same applies for Fb, mu B, Mbj, and mu C, Mcj. This we will discuss in details later, because it depends on the condition that the system is in stationary or is moving. And this frictional coefficient can be kinetic or it is static. But But let's come back to this case that you consider A as your system. So A is the system, then there is a force between B to A, which is in opposite direction of movement, and there's a force between C to A, which is driving force and in the direction of the motion. And then the mass and the reaction force NA, MAG, they cancel each other. So we can say FC on A minus FB on A plus FA, which is a frictional force only for object A. That is equal to MA times A. This is when we consider A as the system. Now the last part, if we assume B is the system, F, and then B, this is the system. In this case, the force which is between B and A, this is the force from A to B. This object pushing it, push the B in this direction. And then there is a frictional force from the bottom surface to object B, which is FB. And then the reaction and the mass. So if we write the equation in this situation, when you have B as your system, FA over B, this force is your driving force minus the force that is the friction, and this is MBA, the mass of the system. One thing here we will realize that every mass, when this F acting on the whole system, if you move step by step, every mass absorbs or take part of this force for its own movement, and the rest transfer goes to the rest of the system. And therefore, when you reach here, part of the force F, which is F C to A basically, when you consider this C to A, that would be the part that will move A, for example. Or the B, when you reach to B, the part that part of the F is spent on moving C and A, but the rest will remain for B to move it forward. So mass, in order to move, needs part of this force, and step by step part of the system, they absorb this force that they need to move. We can have also more sophisticated mode. We can have different, we can consider this as a system. Therefore, this part will absorb the force and the rest goes to move B. And this is our choice and depend on the problem and those unknown things that we want to, variables that we want to measure them, we can solve different equations and analyze the system.